All right, everybody. I believe this is our last topic on matrices. So that's awesome for new material. And what we're going to talk about, we've kind of already hit on a little bit. So we're just going to wrap up what we've already talked about a little bit, which is sometimes we can have matrices set up like equations, and we'll have to deal with them appropriately. So let me give you an example. I've got 2, -1, 5, 3. And then I've got A, B, C, D equals -6 and 17, 7 and 4. Okay, so this is what we mean by a matrix equation. We've got some matrices in there doing some stuff right here on the left-hand side. These two matrices, what's going on? They're being multiplied, right? Okay, so we've got some multiplication of matrices, and then we have to have an equal sign in there in order for it to be an equation, right? Without an equation, it's just without the equal sign, it's just an expression. So for it to be the equation, we've got to have that equal sign in there. Okay, so this is just like if we had something like, say, 5x equals 10. Okay, we can do stuff with that, right? Okay, what we can't do is we can't do anything with this left-hand side. Well, we can't do anything with the equals until we make this left-hand side nicer, basically. Okay, so we had an example like this before, I think. So let's just look at it. This is saying multiply. This is a 2 by 2 matrix. And this is a 2 by 2 matrix. And remember, before you multiply, you always check, do those inside guys match? And sure they do. So they match. And my answer is going to be the outside, 2 by 2, right? Okay, so how does that work? First row times first column. That goes in the first row, first column position, right? And remember that when we multiply, we just do first times first. So that's 2a plus second times second. -1 times c is a -c. We'll make that simpler in a minute. Okay. And then first row times second column, that goes in the first row, second column's position. So we're going to put what we got here. Okay. 2 times b, first times first is 2b, plus -1 times d, second times second is -d. Okay, and again, we'll simplify that, but that's the process, right? So what about in the second row here? Do it real quickly, see if you can get there. Second row times first column. I've got 5a plus 3c, 5a plus 3c. Second row, second column, I've got 5b plus 3d. Okay. So now, and there's not much I can do with this, a positive and a negative, that's going to be an overall negative, right? And here a positive and negative, that's going to be a negative. But nothing else is going to combine like terms or anything like that. So that's about all I've got. So that's my left-hand side, but now it's a 2 by 2, right? It's not some multiplication stuff. Now it's a 2 by 2. And that equals the right-hand side, and sure enough, that's a 2 by 2. So remember, if I have matrices with the same size, 2 by 2 and 2 by 2, and they're set equal to each other, then that means corresponding elements are equal, right? So first row, first column equals first row, first column. So we did a little bit of this last time, right? You can make an equation out of that. So let me do it. 2a minus C, that's this first row, first column, equals what? -6, right? Okay. What about first row, second column? This guy and this guy. What's that going to give you? See if you can come up with that equation. So it's going to be what? 2b minus d equals 17. Okay. So sure enough, we've got that guy. Do the next two real quickly if you can. So second row, first column, set those equal to each other. Okay. And second row, second column, set those equal to each other. Okay. And once again, I've got 4 equations and I've got um 2 of them have a B and a D in them, and 2 of them have an A and a C in them. So we call that what? It goes back to the beginning of this unit's material. 2 equations with 2 variables. So we've got systems of equations here. Let me put them together. 2a minus c equals -6. 5a plus 3c equals a 7. Okay, that's these two with the a's and the c's. That's one system of equations with 2 variables. And the other one is this system of equations. 2b minus d equals 17. 5b plus 3d equals a 4. And again, 2 equations. We've got 2 variables here, but they are different variables, so they will solve differently, right? So the whole thing solves up differently. But we can solve those. We've been doing this for a while now. So I would say real quickly, and I'm going to let you do any method you want. For instance, when I'm looking at these, I think I might want to do elimination because as I look right here at my C terms, one's a positive and one's a negative, I think it might be pretty easy to cancel one of those out, right? To get it to go away. And same thing here with the D's. One's a positive, one's a negative. I think I could eliminate one of those variables as well. So I think that's the way I'm going to handle this, but I would like for you to think, well, which way do I want to handle this? Maybe you prefer to solve this for C and substitute. I don't know. So figure it out. I'm going to push pause. You push pause. We'll come back and see if our answers align. All right. All right, so hopefully you took a minute to do that problem. I've got 2 systems of equations. I solved them like this. Here they are. I was trying to keep it on one page. So I multiplied the first equation by a 3 all the way through. Don't forget to multiply it all the way through. So remember, this goes times here, and times here. At first, I didn't multiply by that -6, and it did not. I was like, oh, that didn't look right. Okay, so it's -18 here. Add them together, the -3c, the positive 3c go away. I get 11a equals -11, a equals -1. And then to get the other variable, you just substitute that back in, remember? So go back to the first equation. It could be either equation. I went to the first one, stick in a -1. I've got this -2 minus c equals -6. Add the 2 over, I get -4, c equals 4. Okay. So I've got 2 numbers there. And then I did the same thing basically with this other equation, except that, of course, the constants are going to look a little bit different and the variables are different. So I multiplied by 3, the d's went away. I got 11b, that's a b, b is in boy, equals 55, and I got b equals 5. Okay, so then I stuck that b back in there, 2 times 5, and I get d equals -7. Okay, so this is one kind of matrix equation that we can do where, hey, there's some multiplication that needs to go on there, and we can work it out and see what's going on. Okay, but there's some other stuff that happens too. So let me show you an example of whenever they want me to start with a matrix and write the system of equations. Okay. So it's very similar to the last one, except for instead of, so this last one, we just had 4. They basically were constants, right? That we solved for, and we didn't know what those constants were. We were just finding out, okay, this guy times this guy gives me this guy. So what do those A's, B's, and C's and D's have to be? But in this one, it's actually going to be like a system of equations. So, but it's going to start with matrices. Okay. So let's say I've got 5, -1, 3, 2, and I'm multiplying that by a very skinny matrix. It's 2 rows and 1 column, okay, X and Y. And what they call this, and if you went on into a higher level like linear algebra or something, is they'll call this my variable matrix. And I'll show you in just a second how we figure it out. So let's think about this. First of all, can I multiply these? 2 by 2, 2 by 1, The inside numbers match. So yes, I can multiply, but my answer is going to be a 2 by 2. I'm sorry, 2 by 1, right? So 2 rows and 1 column. It's the leftovers after I match those center guys together. Okay. So my answer is a 2 by 1. Okay. So, and this one over here, the first matrix, sometimes it'll be called the coefficient matrix. Okay. So these are the numbers that basically we're going to multiply by our variables and get something. And then on the other side, look here, equation that tells me this is a matrix equation. I'm going to have a -1 and a 5. Okay. And this is normally called your solution matrix. Okay, or those are the answers, right? That's the other side of the equation. All right. So how are we going to do this? And what's going to happen is we're going to multiply it just like we normally do, except for here we're going to have first row, first column, and there's no more columns for me to multiply by, right? So it's just going to be first row, first column. So let's see here. It's 5 times x. It's going to work the same way we're used to. 5 times x plus -1 times y, so that's a negative y, okay? And that's first row, first column. That's it for that first row, first column. I don't have a second column, okay? So then what about the second guy down here? Okay, it's second row, first column. Well, second row, first column, that's that space right there, right? Okay, so let's see. 3 times x plus 2 times y. And look at how basically we're going in reverse from what we're used to seeing here. Usually we would see a system of equations with x's and y's and we would change it into a matrix. But in this case, we have a matrix, a coefficient matrix, times another matrix, a variable matrix, and we're coming up with, oh, that's what it looked like before I dropped the x's and the y's, right? So I'm not done yet, but it's interesting how this happens. And then my solution matrix over here on the right-hand side, I didn't do anything to it, so I'm just going to copy it down, okay? And now we can use that same process that we said a little while ago that says, hey, this guy is in the same position as this guy. They are corresponding. They're both first row, first column. And so what can we say? If they're in the same position, they must be equal to each other, right? They must be equal. So I can sure enough come back and do that. So 5x, I'm going to make that a minus y equals -1. That's my equation. Okay. And then what about second row, first column? Second row, first column. Well, those two are in the same position, right? So what does that mean? We can set those equal too, right? They're in the same position. They must have the same value. So 3x minus 2y equals 5. And look at that. That's a system of equations. Two variables, two equations. Okay. So we call that two equations with two unknowns, right? Now we have a system of equations. Okay. And these problems didn't ask me to solve. They just asked me to rewrite it so that it looks like a system of equations. So that's how that is done. If we then, back here to the directions, write the system of equations. If they then said, okay, now solve your system of equations, then we would, I don't know, maybe we multiply the first one by 2 so that the y's get eliminated or something like that, right? So that's where that would end up at. All right, let's see another example of this. They get more complicated, right? Of course they do. They have to. They always get more complicated. -8, -6, -3. So this is going to be a 3 by 3 matrix. -3, 0, and 4. -4, 8, and 6. So I've got a 3 by 3 matrix. And if this is my coefficient matrix, this guy is going to be my variable matrix. What do you think my variables are? Probably x. And the second one is y. And what do you think the third variable is? Z. Yeah. X, Y, and Z. Okay, so it's going to work out very similarly to what we already had. But this guy, because he's a 3 by 3, over here I've got 3 by 3. This guy's a 3 by 1, 3 rows, 1 column. These numbers on the inside match, so indeed I can multiply them, and my answer is going to be what? 3 by 1. And that is actually really important that it's a 3 by 1 because that sets it up so that there's only one unit, and I can set them equal to whatever's on the other side, which in this case it is 8, -4, and -3. Okay. So I'm going to skip the thing where I do the matrix multiplication and write that down. You can do that step if you want to. I'm going to head straight for my equation. So let's see if we can do it. First row times first column. I lied. Let me go ahead and write it because I don't want it to get too crazy here. Okay. First row times first column. That's -8x plus -6y. So plus and a minus is a negative. Plus -3z. Okay. And remember that's only one column across. That's 3 by 1, right? So that is my first row, first column. Okay. And then the second one is here. Second row times first column, -3x plus 0y equals, I'm sorry, plus 4z. Okay, so I've got my second row first column, and again, that's just one big guy, right? One big term. Okay, so that's fine. And then my third row first column, -4 times x, or -4x, plus 8y plus 6z. All right. So now I've done my multiplication, and it's all equal to 8, -4, and -3. Okay. So I did that multiplication. If you felt like, oh, I can say this is first row, first column, he's got to be equal to the 8. This is second row, first column, he's got to be equal to the -4. This is third row, first column, he's got to be equal to the -3. You can totally do that if you feel like you can skip that one step. Normally, I want to see all of your work, but I'm okay if you combine those two. So what I get is -8x minus 6y minus 3z equals 8. Let me stick it right here. Okay. I'm just saying, hey, if you're in the first row, first column, you're equal to the first row, first column. Okay. So then what? -3x plus 0y plus 4z equals what? -4. That's right. And then the last one here, last row gives me -4x plus 8y plus 6z. And it's going to be equal to what? -3, right? Okay. -3. Absolutely. So that is my new system of equations. And notice that what we've done here is because we had the equal sign, we stuck this all together as one big equation here, one big equation here, one big equation here. So basically we have 3 equations and 3 variables, right? So that's where a 3 by 3 comes from. That's why we call it 3 by 3. Now, if I were to put this into a matrix, now that I've got it written as a system of equations, I would probably do what? I'd probably set it up so that I've got an augmented matrix, right? If I had an augmented matrix, I'd have my X guys, my Y guys, my Z guys, and then the number out here, right? Because I'd have 1, 2, 3, 4 columns. And now there'd be 1, 2, 3. That guy would be a 3 by 4 because now it would pick up the solution side of things, right? Okay. So just realize that kind of that leads you back to solving a system of equations, and we can do it with a matrix or we can do it other ways. And on a test, it's going to be important that you know how to do all the different methods, because I'm very likely to say, solve this system of equations using substitution, solve this system of equations using elimination, solve this system of equations using matrices. Or you really need to be careful and read the directions, because the directions for this problem and the last problem both said, start with a matrix, write a system of equations. It does not say solve. So if it does not say solve, don't waste your time on that. And a lot of people can get bogged down sometimes when you're like, oh, I didn't need to do that. Okay. That's why if you see me write on an exam, stop. It's because I'm like, you're doing too much work. I didn't ask you for all that. Okay, so what's the upshot of this? The upshot is, hey, we can always do stuff like find values for X and Y. Okay, because we can stick all this stuff together, all the systems of equation stuff, all the matrix stuff, and we can solve for X and Y. We know how to do that. Okay, so this guy, it's got a matrix, the coefficient matrix, -4 and 1, 2 and a 4. And the variable matrix is an X and a Y equals, and I've got a 17 and a -22. Okay. And it says find values. That's the same as saying solve for X and Y, right? Okay. So we're going to do this the same way we did a second ago, but we're going to go ahead and solve it. So again, this is a 2 by 2. This is a 2 by 1. I can multiply because they match. The answer is going to be a 2 by 1, right? So let's see. -4 times X plus 1 times Y. Just going to write Y. And then I've got 2 times X plus 4 times Y. Okay. So that is putting together my coefficients and my variables. So I've got them as this nice, pretty 2 by 1 matrix. Excuse me. And my solution matrix over here is also 2 by 1, right? This is all together 2 by 1. And this is 2 by 1. So now that I have the same size matrices and they're set equal to each other, we're going to just get corresponding parts and stick them together. Okay, so I've got -4x plus y equals 17. That's top equals top. First row equals first row. And then I've got 2x plus 4y equals -22. That's the second row equals the second row, right? And sure enough, that is a system of equations. We've got 2 equations and 2 unknowns, 2 variables. All right, cool beans. But it didn't say write this as a system of equations. It said, oh, excuse me. It said find the values for X and Y. We can do that. Okay. In fact, I'm looking at this right here and I see, and I always look for this, right? If I think I might be able to do elimination method, I'm looking for where one of the variables is positive and the same variable in the other equation is negative. So here I've got a positive 2x, here I've got a -4x. I know I can eliminate the x's if I'll only multiply this second equation by what? Multiply by 2. That's right. Okay. I'm not going to do anything to the first equation. So that's going to stay there. -4x plus y equals 17. But that second one, I'm going to distribute that 2 all the way through. So 4x plus 8y equals -44, right? All the way through. Okay. Now I see. Oh, look at those guys. Opposite signs. When I add these together, I am going to be A-OK because that is going to zero out, right? They're going to be eliminated. So I got 0 x's. I'm going to do y plus 8y is 9y equals I don't want to do this math in my head. Let's get our calculator because I'm going to be a lazy bum. Negative 44 plus 17. I'm sorry, guys. I know. It's been a long semester. Okay. And remember to use your negative sign down there on the bottom, not the minus. If you push the minus here in the negative 44, it will give you an error. Okay. So it says negative 27. So 9y equals negative 27. And then sure enough, for that guy, we can solve for y. Y must be what? Divide by 9, negative 27 divided by 9 is a 3, right? Okay. Am I finished? No, I'm not finished until I get both values. It said find values for x and y. And I have one of them. I have the y value, but I do not have the x value. Okay. So again, we plug that back in. We did this a minute ago. So here we go. Negative 4x plus, and instead of y, I'm going to put negative 3 equals 17. And then I'm going to have negative 4x. I want to get rid of this minus 3. So I'm going to add 3. Those will eliminate. Add 3. And I've got negative 4x equals, that's going to be a 20. And then last but not least, I need to divide by the negative 4. Okay. And I get x equals 20 over negative 4 is negative 5. Okay. So sure enough, I get negative 5 and negative 3. And you can, like we did this before, if you want, you can write it as an ordered pair if you want. These were both linear equations, right? So it's a system of linear equations. This takes us back to the very beginning of this unit when we were solving systems of equations through elimination. And my answers are x is negative 5, y is negative 3. And there we go. We got our answer. Okay. All right. So I will say for an exam, I will not be mean to you. You're not going to have to do one of these as a 3x3. Okay. You're only going to have something that was a 2x2. Okay, so don't worry about any of the more complicated stuff. You might have to write an equation or something like this with the 3x3. Sure, you can write those systems of equations, but to actually solve like this, okay, I'm not going to do any that have x's, y's, and z's. You will only be responsible for x's and y's. Or if I put it on there, maybe it's a bonus, but it's not going to be expected of you to do all this. Okay. All right, so let's do one more of those. Find values for x and y. Okay, and it's going to be similar. I've got a matrix that's 1, 4, 1, 1. These are my coefficients. I've got a variable matrix that's x and y, but this one's got a little extra step in it, so plus 6, 7 equals 27 and 16. Now we're doing something where we got some stuff, we're adding some numbers, we got that. You have to kind of check again, make sure we're okay. This is a 2x2. We're multiplying it by 2x1. We know we can do that. We just did one like that. My answer is going to be a 2x1. Okay. And this is addition. So go back a couple of sections ago when we did adding matrices. What's the requirement for being able to add them? They have to have what? Same number of rows and columns. That's right. They have to have the same dimensions, right? So as long as this is a 2x1, whatever my answer here is, and this is a 2x1, I'm going to add those. I'm okay there. And then same thing happens whenever I come over here to say equals something, right? I can only do corresponding parts, again, if they're the same size. So all of these, whenever I'm finished, the multiplication, you just check it. Check that your answer is going to be something that you can add to a 2x1, and then it is. So then can I set that 2x1 equal to this 2x1? And I can. So this is a legit problem. We can do this. Okay. We know we can do this math. So here I am. I'm going to say at least pause the video and do the multiplication here. First row times first column, second row times first column. You know, you get a 2 by 1. At least pause it that long to see what you get. And then when you come back, if you need to, you can see me add them and set them equal. If not, you might pause it a little bit longer and work the whole thing out. All right, give me a second. All right, so I've done my multiplication, and I think I've got x plus 4y, and I think I've got x plus y. And I haven't done the addition yet. So hopefully that is your new 2 by 1 matrix here, okay? And then the rest of it should hopefully come pretty easy. I'm going to kind of do this so we can see first row, guys. They're all first row, first column. So x plus 4y plus 6 equals 27. And I'm going to have to clean that up a little bit, but that's okay, right? We can see that. We can do it, okay? So what about the second row? I think it's x plus y plus 7 equals 16. What do you think about that? Oh, was it 16? Hang on. I'm just making sure I copied right. 27, 16, 27, 16, 27, 16. We're good. Okay. Just making sure I didn't mess anything up on my process. Okay. And of course, I do have X's and Y's. I have this extra guy here, but don't let that throw you. It's just an added in number, and it's actually a constant, right? So we know we can move that over on both of them. In order to get rid of this 6, to move it over, I need to eliminate it on the left-hand side. I'm going to subtract it on the right-hand side. Those will go away. X plus 4y equals 27 minus 6, 21. And then here, x plus y equals, I'm going to subtract 7. 16 minus 7 is 9. So that's what we've got going on here. And yeah, that's doable, right? We can deal with that. Okay. Now what? Solve this guy. We can do it. In fact, I can eliminate the x's very easily. All I got to do is multiply everything by -1 here, right? Okay, so let me rewrite this. X plus 4y equals 21. Negative x minus y equals -9. I just changed the signs on all of those. And sure enough, those x's will go away. And what do I have? 4y minus, because I'm adding these together, right? 4y minus 1 is 3y. 21 minus 9. If it was 11, it would be 2. This is 21, so it's going to be 12, right? Y equals 4. That's not bad. Okay, and one more time. How do I find the x? I'm actually going to come here. Negative x minus 4 equals -9, just because I don't want to multiply the 4 by the 4, so I'm just going to kind of cheat a little bit. To get rid of that 4, -4, I add 4. Those will go away. Negative x equals, that's a -5. X equals 5. So this guy's solution is 5, 4. Okay, so sure enough, we can work that out. It's okay. Not too shabby, right? All right, so that's the idea behind these matrix equations. Those are the basics of it. This is actually probably going to be a relatively short video, but I actually want to do a word problem on these because this is one of those times where you go, oh, when am I going to use this? What's that business application? Why are you bothering to teach me this? I'm going to be, I don't know, an accountant or something like that. So here we go. Okay. Here's your example that's all about the applications. We have a factory that makes slalom skis. Slalom. Can't spell. Slalom skis that require 3 labor hours to assemble. Okay, so on our factory floor, we have an assembly department, and it takes 3 hours in that department for us to put together Maybe we had to cut out the slats for the skis or whatever, but we put together, we assemble these skis, and it takes me 3 hours, okay? And 1 labor hour in the finishing department. Okay. So what does that mean? Takes me 3 hours to put them together, and then somebody probably comes back and maybe they sand them, maybe they stain them, maybe they gloss them, that kind of thing. So how long is it going to take us to make these skis? Okay. 4 hours total, right? That's what we're talking about. Okay. So this is going to be part of my information. Hold on to that idea. We'll talk about it how we would set this up in a second, but there's a second part to this problem, okay? And that is assembly people, assembly workers make $9 per hour, and finishing people make $6 per hour. Okay? And the question is, how much does it cost to make a set of skis? Okay. And again, this is probably some of that stuff that they're doing in the back room. This is not somebody out on the factory floor probably dealing with this, except that they're probably gathering data like how long does it take to assemble them? How long does it take to finish them? They gather that data, they throw it to somebody in the back office or front office, depends on how your factory looks at it. And those people are doing the math or whatever, setting up a spreadsheet like we're about to do. Okay. So there's two different things going on here. One is talking about the hours it takes to make a ski, and one is talking about the money the employees make per hour. Okay. So I'm going to actually have two different um, matrices here. And one is going to go side by side and it's going to look like this. Okay. So it's going to be assembly hours. Okay. This is going to be my time matrix. Okay. Assembly hours. They take 3 hours in the assembly hours, and the other column is going to represent finishing. So how many finishing hours does it take to make one of these sets of skis? 1 hour, right? Okay, 1 hour of labor. Okay. And then we're going to go into a vertical matrix, and you'll see this in the form of a spreadsheet if you see something like this. And this is going to be my pay matrix. Okay, because I need to know how much everybody's getting paid, right? And so when I multiply here, I'm going to go assembly times this guy right here. Well, I need to have the assembly amount here, right? So this one came first. So the assembly amount per hour comes first. So that when we look at this, we're going to take 3 hours to make it, and we're going to pay those people $9 an hour. It's going to be $27 for assembly time, right? And so what number should go here? 6. Yep, $6 per hour for that will be the finishing people, right? I'm going to multiply those together. So assembly times assembly, finishing time finishing. I got to make sure those add up. We know one's going to be a horizontal matrix and one's going to be a vertical matrix. Okay. And we want to know what this is. We want to know how much this is going to cost. So what do we got? How do we multiply this? First row, first column. Oh, by the way, how big is this going to be? How many rows? 1 by how many columns? 2, right? And then this is 2 rows by 1 column. 2 rows, 1 column. Okay. So indeed, those numbers in the middle do match. So I'm good there. Okay. I can indeed multiply this horizontal matrix times this vertical matrix. And I'll get a what? 1 by 1 for my solution matrix. Okay, so this is not going to be a lot of big stuff here. I'm just going to have to do the math. So let's see. 3 times 9 is 27 plus 1 times 6 is 6. And sure enough, that's only a 1 by 1 matrix. I can do that math. It's $33. Okay, $33 to make a set of skis. In this case, slalom skis, there's only just it's a 1, right? It's 1 slalom ski. It's not a set, but you get the picture. Okay. All right. So there we go. We've got that example. And I want you to do one on your own. It's going to be actually the same project. Okay. Same build up here. But we're going to say instead of slalom skis in our example, oh, excuse me, we're going to say you're making trick skis. So, example, trick skis take 5 hours to assemble. That's going to be more, right? 5 hours to assemble and 1.5 hours finishing time. A little bit longer on the finishing time. Okay. But all the rest is going to be the same. $9 an hour for assembly, $6 an hour for finishing, all that's the same. So what I want you to do is I want you to figure out what your matrices are going to be. Look at these that I've got up here. You should be able to mostly substitute out and be okay. All right, so you go ahead and set up your matrices and see what you get. All right, so I've got it set up like this. I think using the same stuff I had before, assembly is going to take 5 hours, and we're paying those assembly people $9 an hour, so those need to match up. Finishing is going to take 1.5, and we're paying those people $6 an hour. Okay, so let's go ahead and do our multiplication here. It's going to be first row, first column, again 2 by 1, 1 by 2, 2 by 1. This is going to be a 1 by 1 as my final answer, right? Okay, so we know that. So let's see. 5 times 9 is 45. And 1.5 times 6. Well, if it was 1 times 6, it would be a 6. And a half of 6 is 3. So 1.5 is 6 plus 3. That's a 9. Okay. So what is 45 plus 9? 54, right? All right, so that's kind of a nice example of the types of problems. I know in the homework in the My Math Lab, it starts showing these types of work problems that are more business oriented, factory oriented, things like that. So hopefully that helps you get started on that homework. And if you have any questions, let me know. Thanks.